So, new PRs this week. Nothing. I guess it's been a little bit of a slow week. So, there were a couple that closed. Adam's got one here that is related to his RocksDB sharding work to prevent really large Red Hat log sizes from being used. It just puts a maximum cap on them, which is good. There's one here closed by Ching Cheng X for testing of some buffer list encoding work that he was doing. I think Kifu had indicated that he wanted that done in a different place rather than in the test directory, I guess. I think he wanted external to the project rather than internal, I guess. So let's see, what else? I don't know why Adam Emerson's FIFO the data log PR closed. Casey, do you know?
I don't know.
Okay. No worries. Okay, let's see. And then there was an older PR from Majian Peng that was also around locking that got closed because none of us looked at it. So potentially maybe we should reopen that, I'm not sure. It's pretty old though. All right, let's see. Updated PRs. There's one about blocking traces here. I think Igor self-assigned that to look at. He hasn't had time yet, it doesn't look like though. So it's still there. Mempool splitting. Oh, this is Dipika's PR. So this looks great. It's just basically making the mempools much more finer grained, so we've got a better idea of what we're actually using memory for. So that looks fantastic. I think she's just working on fixing it. Another one here about Blue Store locking, and this is the one that I've mentioned a couple times before that I'm afraid of, and I'm still off the hook at the moment because it looks like it's still having some issues passing QA. So for now, at least, they still have things to look at to figure out why it's not working right. And then the last updated one here is, my PR. So this is kind of my ongoing work in the MBS, trying to figure out how to make CephFS faster for scenarios where you have lots of readers and writers hitting a single directory, potentially with many, many files, and lots of MDSs. So I can talk a little bit about that more later. Otherwise, not a whole lot here. I don't think there's anything in the no movement section that's now. Maybe the only thing is that we should still try to, if we can, get a couple of Igor's PRs in here. That would be good. The reduced memory footprint one would be really good to get in for the next release. And the simplify onode pin and unpin logic, that's probably the most important one, actually, that we get in. So I don't think we have Igor. No, he said he was going to try to work on it, though. So hopefully we'll get that in the next week or two here. Otherwise, the only other one of mine that probably would be good if we can get it in is the double caching, onode caching one, which I have not looked at, but I told Niha that I would try to get it done. So that's also on the list. All right, anything I missed for PRs, guys? All right. So the only thing I've got here for discussion topics is that in this IO500 testing that I've been doing, it's kind of led me down this rabbit hole. Initially, I was suspecting that the process of trying to fragment and export directories in the MDS was causing a lot of slowdowns and stalls. And I still think that that's not false. The last week I ended up taking the pre-fragmenting code that I had written and extending it to also pre-export those fragments. So I got that working on Thursday or Friday of last week, and it appears to more or less work fine. And it actually does help when we have a smaller number of MDSs. Like if you have the test I was doing had 9. In that case, it was significantly helping. We immediately saw all of the MDSs working together to service requests for a directory that was really busy with lots of files and lots of clients. So that was good. It kind of did more or less what I wanted to do. When I bumped the number of MDSs up to 65, I saw very similar behavior to what I saw with dynamic subtree partitioning. We still got the benefit of immediately having all of the MDSs doing work, so that was good. I mean, it's still a little bit better in that way, but the throughput was very low, like maybe a couple hundred ops per second per MDS, and there were periodic stalls and slowdowns and weird behavior. So what I ended up doing is I noticed that the authoritative MDS for the directory was always really busy, and profiled it using GDB PMP, and it looks like it is doing a lot of work related to the Cephfs journaling. And most of that work, it turns out, is this e-metablob data structure, where it's decoding buffer lists, throwing a bunch of stuff in maps, and those things that are throwing in it's a combination of dir frags as a key, and then these I think they're called dir blobs that have a bunch of data in them themselves. So that process of decoding all of that stuff is really slow. My initial thought was that it was actually the map data structure that was bad, because I was seeing TC-malloc like going nuts trying to like allocate memory from the central free list, and that's kind of a known thing with standard map. So just as a fun thing, I rewrote it using a vector, and that did solve the TC-malloc issue, but the naive linear search I was doing ended up being incredibly slow. We are actually using the fast search functionality quite aggressively, and we have a lot of dir frags, so that didn't work so well. But the good news is that it actually proved that this is really hot code. That slowed down all of the tests that involved one directory with lots of clients very dramatically. So I next tried an unordered map. I was thinking flat map as well, Matt. And maybe that might be the way to go. But I did try an unordered map, and it didn't change much, where I was expecting it would have.
Well, flat map will help with allocation stuff big time. We've seen it.
Yeah. I think it is the way to go, but I'm actually now less convinced that it was the map itself that was causing problems. Going back and looking at the trace again, what I'm seeing is actually buffer list itself. Specifically, if I remember right, it was append hole is doing all of these small allocations, and I think that's actually what's making TC-malloc freak out. But there's a bunch of other stuff too. I mean, just the encoding overhead is high in general. The map might be contributing to some extent. Just destroying the objects that are put into the map. There are these temporary things called, I think they're dir blobs or something. I don't remember. But those things, just deallocating those, there's like 10% of the MDS thread was just doing that. And it's more or less single threaded. We just have this one big lock in the MDS. So Okay, Flatman wins most when inserting in order. Okay. Yeah, I mean the insertion I think is all inserting it up front during the decode. So I don't even know that we're actually inserting anything after the fact. I think it's just basically decoding. Is decode encode? Whatever. Anyway, it's I think he's only doing it once, and then it's doing a bunch of operations, searching on this thing, and eventually getting rid of it. So in any event, yeah, it's we're using a lot of CPU. We're making TCML go crazy with lots of small allocations, and I assume lots of fragmentation. And the MDS is single threaded, so there's lock contention with the messenger threads in some cases.
We've been in conversations with this over several years. We should really make we should make the MDS multi-threaded. Then we should make libcfs multi-threaded. Take advantage of it.
Yeah.
Of course, obviously the Ceph native clients are already threaded out the Yang, so you get immediate massive wins. I mean, it's obvious, right? The MDS wants to be big. It wants to be a cache. So it's a contradiction to have it then serialize everything.
Yep.
Journaling and Rados is troublesome too. As a thing, but that's another story.
Yeah, Matt, I've had the exact same thoughts you were having right here. I was just hoping that maybe there were some incremental easy wins to be had before taking that step.
Well, you're looking at good stuff, but I mean, but orthogonally, we should drive on parallelism. But having said that, I've talked to people recently about this, like this week or something like that. There are patch sets. People want to do this finally. Trying to get this going for a while. Exciting if someone could make headway there because it matters.
Yeah,
it's great to have proof. It's great to have proof that it matters. I mean, Ben England it's been proved before, but proving it again, it's been proven even more. Double proved at multiple levels.
Yes,
and so on.
Yeah. So, the unfortunate thing, right, is I was hoping that I might be able to make some quick wins for this IO 500 testing that's coming up, because I think the new deadline for it is going to be in like middle July. But I don't know that I'll be able to do anything fast enough to actually, make the hard tests, perform significantly better. So we'll see how it goes.
Quick note in the matter of micro-optimization and buffer list. Append Hall is actually supposed to be extremely cheap, apart one single case. When the append-like buffer is exhausted or is unavailable. In that situation, append Hall needs to go and allocate memory.
Oh.
But append or append Hall or those bunch of methods actually shouldn't do that. In the best case, the entire memory allocation should be served only at the construction of buffer list, and in general by the reserved method. So maybe it's worth checking, maybe it's worth taking a look whether the decoding or the encoding or whatever actually reserves a space in buffer list. Maybe it's not, and it's not only then, it would not only be wasteful in the matter of CPU cycles, but also, and maybe mostly in the matter of wasted memory. Appends, the allocation unit of all our appends is actually 4K. So if there is, for instance, if you create an empty buffer list without passing any hint about its intended size, then first append, or whatever, will give you allocation, which might be actually quite slow.
Radek, I've just pasted a snippet from one of the GDB PMP traces for you.
Okay, so we are encoding. And 15% in the append Hall. Refill append space. Yep, exactly.
Yep.
That's
Yep.
the
Okay.
that's the case, that's the single costly case.
All right. So we just need to fix the encoding here then, so that we are pre-allocating
Maybe.
memory. Yeah.
The question is whether it's possible, whether we truly have an information of how much will be appended. If
We
we
should
have,
be able.
then not you.
We should be able to, I think, because we basically. Yeah, I don't see why we can't. I'm actually surprised that we're not already. Reddick, do you remember how we did some magic like 3 years ago to change the encoding to automatically try to determine this up front, right?
We have two variants of our encoding decoding subsystem. The old one, I mean encoding.h, if I recall correctly, it's not trying to calculate the reservation size before doing the job. But mostly for the sake of Bluster, if I recall correctly, we introduced a new subsystem. It's called deng.h. And this
That's
guy,
right.
the methods like bound, don't recall, encode size or encode bound, something like that. There's a dedicated method, a class that is providing the encoding facility can also define a special method for estimating the required size, the size for reservation. Maybe switching from old encoding.h to deng would be a way to go. Don't know.
Yep, I agree. I didn't remember that that's how we implemented it. So thank you for that, because that will be useful. Yeah, maybe that will be what I'll try next, is just to switch over to the new encoding scheme, because I don't think there's anything there that should make it not work.
It might be also worth to verify how much of the allocation made in append hole, how much of data we are truly using. I wouldn't be surprised if it's terribly wasteful. If we are, let's say, allocating 4K just to append dozens of bytes, it wouldn't be surprising.
Yeah, I wouldn't be surprised either. Okay.
And also, it's the secondary effect is that I bet it's much easier to exhaust the per thread caching pool, the per thread caches of tcmalloc when you are allocating 4K instead of dozens of bytes.
Yeah. tcmalloc seems like it absolutely hates this kind of pattern. Cool. Well, okay. Anything else, guys? This is all I really had.
By the way, there is also a lot of types burned in standard condition variable weight. 32%.
Yeah, I know. It's
okay, but I don't think we can easily address that.
No, not yet. Maybe though. Maybe. I mean, I've been kind of looking around at how some of the locking works, and at least some of it, I think we could start migrating away from this big centralized lock. Maybe.
Anyway,
I'm sure there are issues I don't see yet. So.
Yeah, but it will be complex. Much easier. It will be much smaller. Poking with buffers, poking with the encoding, I think would be much simpler one.
You're kind of breaking up for me, Radek, but yeah, I think if I understand you, working on the append hole issue should be a much easier thing to do quickly.
Encoding is just smaller. It's much more isolated than poking with threading in MDS. I bet.
Exactly. The other thing too is this e subtree map destructor 9.1%, and that's just getting rid of all of these little temporary objects, I think.
Here now I can see.
Yeah.
Nice, around 25%. Quite interesting listing.
Yeah.
Might as well make your single thread go fast.
Yep. All right. Well, anything else, guys? All right. Well, I will be continuing to work on this, so maybe I'll have new interesting results next week. Otherwise, have a great week, guys.
Thanks. The same for you, and see you on Monday.
All right. See you Monday. Bye-bye.
Bye bye.
Thank you.